So let's talk about machine learning a little more generally.
Okay.
It's obviously a very big initiative in many ways at Google. JG, because that's the only way I can pronounce his name.
That's how we pronounce it too.
Took over as head of search, and he's a big proponent of machine learning. Jeff Dean, one of your most senior computer scientists, is pushing machine learning. Sundar, the CEO, has talked about it. So can you tell us more about what Google's doing with machine learning generally without oversharing? Or actually, you can overshare if you want.
Machine learning is a tool. It's like having a Swiss knife. You can use it for many things. It's not appropriate for everything, but you can use it in many cases. Just like with Swiss knife, you probably don't want to try to punch a hole in concrete because it will not work. Same way, RankBrain will not work in certain scenarios, but in other scenarios, it will really make your life much easier. So we are using it where we can. Obviously, we are not trying to deprecate all our manual algorithms because that doesn't make sense for us. Basically, if it's working well, then we prefer not touching an algorithm. But we are experimenting with what else can we do in ranking and in other products in general with machine learning.
So, I mean, people hear about machine learning and they assume that it's in general just going to be better than any human-generated algorithm.
No.
But that's not true.
That's not true.
Right. So, what are some of the problems with machine learning algorithms? What are reasons why you wouldn't use them?
Scarce data, for example. If your training data for the machine learning algorithm is very scarce, then you will get really weird results. We have this problem all the time where either we pick the wrong training set, wrong data, and then the results just look just odd. Or we just don't have enough data to actually start using machine learning for something. And then you have to step back and you have to ask yourself, is machine learning the right approach to this problem that you want to solve, or a manual algorithm would do much better? And very often, a manual algorithm will do much better just because you don't have enough data or your data is just way too noisy even for machine learning algorithm.
Right. So in many cases, then, human-generated algorithms are better than a machine algorithm.
Yeah, absolutely.
And I think one of the reasons that I've heard people talk about for that is when it's a human-generated algorithm, the people who work on it have an intuition as to what it's doing and how it's working, and that's harder with a machine algorithm. Yeah,
especially with deep neural networks, when you have multiple layers of neural networks. It's very, well, I guess close to impossible to track back the decision flow of the algorithm. Let's say that you already trained an algorithm and you have your neural network. In every layer, you will have tons of neurons that are basically making decisions. And based on the decision in the next layer, it's the question, let's say, is routed to a different neuron. And if you have multiple layers, it's close to impossible to track back why a specific decision was made. We have tools to debug some of these issues, but generally that works by simplifying the neural network, basically creating a single layer linear decision flow, and then you can track back what happens inside, or, well, you can make a good assumption about what's happening inside the deep network.
Right. So if I were to summarize that, then one of the issues is that when you are doing machine learning, you can't necessarily, well, you don't necessarily have the right data set to train the algorithm well. So that would be one reason for not using it. Another reason might be that your human-generated algorithm is working really, really well, and since you understand it really well, there's no need to replace it with something that's actually harder to understand.